In this video, we're going to take a look at chemical and physical changes. So, matter can undergo changes. It can be transformed, or you can change it in some way. You can change the way it looks, for example, or you could change its identity. You can change what it actually is. So, matter can change physically. It's called a physical change, where you change the matter or the substance without actually changing what the identity is. So, let me just give you an example. Here we have H2O. The identity of H2O is water. It's H2O. It's made up of two hydrogens and one oxygen chemically combined together. And I'm going to say it's liquid. And then I'm going to heat it up and I'm going to make it, well, become a gas, H2O gas. So I'm going to basically evaporate it, boil it, evaporate it. So we went from liquid to gas. But what I want you to get here is that this was a physical change because even though it's now gas, it's still H2O. So we did a phase change, but we didn't change the identity of the substance itself. Or if I were to take a carrot and chop it in half, it's still a carrot at the end of the day. Chemically, it's still a carrot, so it's a physical change. A chemical change, on the other hand, that will change the substance and essentially make a new substance from that first substance that we did. So, property change just means that properties of substances can change. If you have a physical property change, the physical properties have changed, but you didn't change what the actual substance itself is. So it's still H2O, for example. Um, if you have a chemical property change, you've changed the properties um, because you changed what the substance itself was. So let's do another example here. Let's say I took some water, liquid, and I passed some electricity through it. And when you do that, that's a famous reaction. It'll actually break the water up into some hydrogen gas and some oxygen gas. And so what I want you to notice here is that we no longer have H2O. We have some H2 gas and some O2 gas. So we've changed this at the chemical level. We change the identity of the substance. And so with chemical changes, there are certain clues that tell you that a chemical change happened. And we can use this little trick over here, POG-TLC, to remember what those clues are. And so we'll take a look at those clues as well throughout this lesson. We'll start with physical changes first. We'll go through some examples. Again, a physical change, you're essentially changing the appearance without changing what the substance actually is at its basic chemical level. So phase changes are very common examples. When you take ice water, you heat it up, it becomes liquid water, heat that up, it becomes gas. We're still H2O. The identity is still H2O, two hydrogens, one oxygen chemically combined together. We didn't change what the chemical itself was, but we changed its state. And so that's a physical change. If you take a piece of paper and you crumple it or you rip it, that it's still paper. The chemicals deep down are still paper. So that's another example of a physical change. If you, let's say, cut some wood or cut a carrot, if you those did not change what the wood was on the inside at the chemical level. So it's considered a physical change, for example, or same thing with the carrot. Other examples would be melting at freezing, melting, boiling. Those are all physical changes. Cutting something, breaking something. One that students often get confused is dissolving. Dissolving is still considered a physical change because you're not changing the identity of the substance. So, for example, if I'm taking some water, which is H2O, and some salt, NaCl, and I put the salt in the water and it dissolves, you still actually have NaCl and H2O in there. It's just that the NaCl is hidden within the H2O molecules. So the identity of each substance in there remains the same. You still have NaCl, you still have H2O, they're just now dissolved. And so here we have a physical change. The carrot did not change at the chemical level. Now we get to chemical changes where you do have a new substance that forms, and that's the key concept here. A chemical change will typically happen during a chemical reaction where a new substance is forming. The identity has changed now, and so One common example is just burning paper. We said ripping paper was physical and crumbling paper is physical because the chemicals in the paper are still the same. But if you burn paper, you're now converting those chemicals in the paper into some new substances. So we'll take a look at something that's very similar to burning paper. This is burning sugar. And so the compounds in paper are very similar to compounds in the sugar compound here. When you're burning, you're combining with oxygen. And what happens is the compounds of the sugar or the paper are converted into CO2 and H2O, and then they release energy. But the point is, you have new substances here that have formed compared to these old substances that were here before. They're still made from the same atoms, but they're now different compounds compared to before. And so that's an example of a chemical change. Typically, when you're cooking something, so you're frying an egg, for example, or cooking a steak, or um, cooking some vegetables, that would be an example of a chemical change because you're changing the chemicals within the substance. Or rusting, so when the car rusts or when some metal rusts, it's reacting with oxygen and you have new substances forming. If you're burning something, if you see the keyword reacting, that typically means that you're going to have a chemical change. Rotting. So, for example, when fruits rot or anything rots, you have chemical reactions that are happening, and the identities of the chemicals within the fruit or the substance are changing. How do you know if a chemical change happened? It's hard to tell. You do need some experience to realize that a chemical change is actually happening, but there are some clues you can use in the lab. So when you're doing a lab and you put two substances together, you want to know if there was a change that happened, a chemical change specifically. And so one common indicator that a change happened would be a color change, or a chemical change happened would be a color change. So if you mix two substances together, they were both colorless, and all of a sudden they have a new color, that is an indication that there was probably a new substance formed, and you're seeing that new substance's color. A temperature change. So the temperature change, if I mix two substances together and all of a sudden they start to get hotter or colder, then that's probably an indication that the new substance that formed led to that energy change with the breaking of bonds and forming of bonds. So you can see here we had initial temperatures. Then when we mixed these two substances together here, the temperature rose. So there was most likely a chemical change that led to that. Precipitate formation inside a liquid. So precipitate really means like solid chunks, little solids. So I could take two solutions, two substances that are dissolved, mix them together, and then I see this cloudy substance that forms. And the cloudy substance is usually a little solid, is a solid that doesn't dissolve and builds up in the solution. And so if I left it over time, the solid would actually kind of just build up at the bottom there, almost like sand at the bottom of water. So precipitate formation is another clue that a chemical change happened. Odor and taste change. I mean, we're not going to use taste in the lab, but odor is a common indicator that a chemical reaction happened. In grade 12, you'll actually do some reactions where you mix these substances together that start off smelling pretty bad, and then when you put them together, they'll smell like maybe mint or banana or oranges or peach or strawberry, or it depends on the combination. But an odor change could be an indication that a chemical change has happened because you have a new chemical that was produced, and that new chemical, that new substance, has a new odor. Production of a gas. So I might mix two substances together like this, and then we see some bubbling. And usually, bubbling means there's a gas that's being produced, and that gas is a new substance that was produced. So typically, when we know there's a gas because we see bubbling, bubbles. And then emitting light, or light energy. So if you've ever broken a glow stick before, the glow stick, essentially the way it works is you have so here we have our plastic case on the outside, we have a glass case on the inside, and then we have some liquid surrounding that. And so this liquid is let's say substance A, and on the inside of the glass there's substance B. When you crack the glow stick, B and A mix together, they make a new substance called C, and that releases energy in the form of light. So the temperature in the emitting light, those are really just, I mean, you can think of them as kind of the same thing, not always, but they're just changes in energy essentially. So with temperature, the energy is released or absorbed as sort of heat, whereas with light, the energy was released as, well, light instead. So we saw that there are physical changes where you don't change the identity, and chemical changes where the identity does change. There are clues that will let you know if a chemical change has happened, and these are the main clues that tell you if a chemical change has occurred. You do need to think about it a little bit. There really has to be a new substance forming, otherwise it's not considered a chemical change, and we'll take a look at some examples shortly. So color change, you have a yellow color, colorless over here, mixed them together, and you have this new color that formed, red, and that's from the new substance that has formed. Here's another example. This is a nutrient test to see if there's any starch in your food. So what you do is you take a piece of the food you're trying to test, to say it's cracker, and over here we have a solution called iodine solution. It starts off brown, and we're going to put a drop on it on the cracker. And if there's starch in it, starch will react with the iodine solution, and the iodine solution will become like a dark blue color. And so there we see an example of a chemical change, and the clue was the color change. Over here we have temperature change, as I mentioned. So we have two initial temperatures, and then when we mix the two solutions together, we can see the temperature rose. So we have a higher temperature than before, and that's because energy was released in the form of heat to the environment. Sometimes you might have a temperature change going the other way. So we could have had the temperature go down, and that's a possibility as well. But the point is, there's a temperature change. And this temperature change doesn't happen because we heated it up. We didn't put this on a stove or anything, or put it in the microwave or whatever, or on a hot plate. This happened strictly because we mixed the two solutions together. So it's a change in the temperature without you having to add heat or remove it in some way. Precipitate formation, as I mentioned, they're basically solid chunks that form. So you might have two solutions that are there's no solids in them. Everything's nice and dissolved. When you mix them together, you see this cloudy stuff that starts to form. That's the solid. That's the precipitate, and it usually piles up at the bottom if you wait a little bit, almost like sand in water. Don't confuse this with freezing. I didn't put this in the fridge or in the freezer, I should say, and then convert it into a solid. No, there were no solids present at the same at room temperature. I mixed them together, and then a solid appeared within it because now that new substance could no longer stay dissolved in the water. And really, looking cloudy is that indicator that a precipitate has formed. So here we have, I'm putting a drop of a solution into this solution over here. I basically just combined lead iodide and potassium iodide and lead nitrate. They were both solutions with no solids in them. And then once I mixed them together, they made a solid, and that solid's actually lead iodide. It no longer dissolves in water, and then the other stuff that stayed dissolved in there, and this should not say liquid, this should actually say aqueous over here. This should say aqueous. Um, the other stuff that remained dissolved was the potassium nitrate. The point is that we have some precipitate that formed, and that was an indication of the chemical reaction. Odor, flavor change. So if you've ever tasted spoiled milk or rotting milk, you could tell it doesn't taste the same that it used to, or it smells gross as well. It smells kind of weird, and that's because the new substances have a different odor or taste. Again, you wouldn't be tasting in the lab. Production of a new gas. So very common example is mixing baking soda and vinegar. When you mix baking soda and vinegar, you see bubbling that happens, and the bubbling is because some carbon dioxide was produced, and that's a new gas that was produced and is being released. Don't confuse this with boiling, right? When you put water on a stove and it starts to boil and you see bubbling, well, that's just, again, the process of boiling, evaporation, that's a phase change, that's a physical reaction. You really need to make sure the bubbling is a result of the new substance being formed. And then, like I said, production of light as well. Here is an example of a chemical reaction that happens in fireflies. You have a chemical here called luciferin. When it reacts with oxygen, it makes oxyluciferin. And in the process of that, it releases energy in the form of light. So let's quickly go through some examples of changes, and we're going to decide if they're chemical changes or physical changes. And so here we have rusting, and rusting happens when iron reacts with oxygen in the atmosphere. So based on that keyword reacts, we know that this is probably an example of a chemical change. Here we have glass. We're heating up the glass until it melts. So remember, melting is a phase change. We're not changing the chemical identity of glass, so it is a physical change. Here we have a banana rotting. And when they rot, they become brown and they smell bad. So a couple clues were given here. First of all, rotting we know is typically a chemical change, but if we didn't know that, we can see we have a change in color and also a change in odor. And so that would indicate that we have a chemical change. Here we have marshmallows. So when we're roasting marshmallows, they turn black over here. And that black substance that actually forms on them is actually carbon. We will often call that soot. So that's carbon that formed there. We do have a new substance that formed, and that's the indication there's a color change as well. But this is a chemical change. We're burning, we're roasting, we're cooking something. So we have a chemical change that happened there. Here we have crushing chalk into a fine powder. So we just took chalk and we crushed it. Chalk is actually something called calcium carbonate. When you crush it, it's still calcium carbonate. So it hasn't changed. Crushing something is a great example of a physical change. Here we have liquid water. We're putting it on a hot element. We're adding heat to the water, and you can see some bubbling, and it starts to boil and evaporate. Remember, bubbling can sometimes be an example of chemical change, but it really needs to be because of a new substance being formed. Here we're just evaporating or boiling the water. So since we're just doing a phase change, this is really just a physical change.